Hello, everyone. We just set up the slides, so hopefully it works. Okay, perfect. I see it here. Hello, I'm Burak Gokturk. I lead research within Google Cloud, and at the moment we're focusing a lot on clearly AI, machine learning, and also systems and how we combine them together as well. Today, I think I have about 8 minutes or so. I'll focus a little bit about some of the trends that we're seeing when it comes to AI, and then also tie them into how we're building multi-agent systems and how you can use some of those trends as you design things as well. Perfect. First of all, just a little bit of quick briefing. I think you've all seen that things are moving super fast when it comes to AI and machine learning. Now, if you back up for a second and look at what is happening, actually lots of the algorithms that are working on are from last century. It's all about neural networks, right? And it's a set of weights, a set of hidden nodes, and given some inputs, it's trying to predict the outputs. And again, the main optimization is coming from last century too, backpropagation. Indeed, most of us, like when we were looking at in early 2000s or earlier, neural networks wasn't the best performing AI algorithm. What happened? And we were all thinking even, okay, why is it even in textbooks? It was that bad in terms of performance. We missed a couple of points. First of all, neural networks, both in terms of prediction of the nodes, so separation of how we can parallelize the model weight predictions, as well as data parallelism, it gives you lots of leverage to be able to distribute into many machines. So you could do many of the processing in a parallel manner, especially when you're doing the training. Now, parallelism is only useful if you have lots of data. And so we needed to figure out how to create lots of data as well. And then I think you've seen all of this. People have come up with the concept of masking, which is essentially having lots of sentences, images, etc., and then masking parts of those sentences. For instance, in a sentence like Istanbul is the biggest city in Turkey, you can mask some of the words and then use those words as part of your training set. And all of a sudden, if you use all of the web, you have trillions of pieces of training data and means for an algorithm and a training algorithm for means to be able to parallelize it. So all of a sudden, neural networks literally moved from being one of the not best ones, I shouldn't call it worse, but not being one of the best ones, to clearly the best one in terms of AI predictions. Now, of course, you've seen various papers like attention is all you need. The transformer structures came, again, building on more or less lots of the neural networks as well as backpropagation as well. So we landed where we are. And now let me mention a few of the trends that we are seeing. And we've gotten this through talking to lots and lots of enterprises. And I'll go one by one on these trends, and then maybe give a little bit of a few hints on how you can use as you build your agents and agentic systems as well. So first, maybe about 2 years ago, it was the choice of the model, but that's changing. It's now choice of the platform. Why? This is one of the leaderboards. There are many leaderboards that evaluate how large language models are doing across different artifacts. And if you look at LIMS's chat leaderboard, it's changing literally every other week. And every few weeks, another company is coming up with a large language model that is performing really well. So that clearly says that you need to really focus on the platform also, not just the models. You need to be able to have an access to a broader set of models. And as you build your agents, one thing that you're going to be seeing again and again, you need to adapt these models into your own use cases. And more specifically, that means fine-tuning as well as distillation. And of course, you need a platform with toolsets for agents in production as well. So this is Vertex AI, Google Cloud's AI platform. But in any good platforms, you should see some layers like this. Again, what we call a model garden, a place where you have access to lots of different models. A model builder where you can customize those models through fine-tuning and distillation. and an agent builder with all kind of tool set to be able to move from just models into agents. This is anywhere from orchestration to extensions to connectors, document processing, etc. And okay, let me just go fast. The second trend is really search. One thing that we are seeing from many, many enterprises is that you need to combine large language models with search to build successful agents. The reasons are clear. Large language models are trained in the past, so they will not know the score of the game from last night. They hallucinate, and it's a feature, right? They need to be creative. So sometimes they're not exactly right in terms of factuality. And finally, they cannot cite, and it is very important for many applications to be able to tell where the data is coming from. So with this in mind, maybe one lesson I want you to take home is that you will need to go to search in many of your applications. Now, let me go to the next one, and it's clearly the time for agents. And LLMs cannot do everything, right? So you need to be able to combine it with different tool sets. You need to be able to maybe make multiple LLM calls in your agent. And if you look at the applications that we have seen early days, it was conversations, summarizations. LLMs can do by itself. Now the time has changed. The way I define agents is that anything that agents cannot do just by themselves. So what it means is it needs to use different tools. It needs to do function calling and be able to combine all of that. And again, going to a good platform with the great tool set is going to be very key as you build your applications. These are some of the key attributes. I think function calling is the one that I would like to call out here, as well as probably memory usage as well for personalization. But and function calling is still a challenging task for many of the large language models, because A, they need to figure out that they need to call a function to be able to answer a question, and B, they need to be able to call the right function. It's a challenge if you look at leaderboards. If you give 100 functions or so to choose from, the accuracy rate of choosing the right function is in the order of 50, 60, 70%. So this is one thing to remember. If you're building agents, try to start simple. Do not try to set up an application where you're calling, like, you're trying to choose from 100 different functions. Now, let me jump to the next trend, because I have about 1 or 2 minutes. You're going to see single agents as well as multi-agents as well. I would like to give one example of a multi-agent. This is a paper that we recently published. It's called Co-Scientists. And it's essentially a medical discovery system where, think of you're a medical researcher doctor, and you have a research assistant, and you're telling them to go and make a research. It would go read all the papers. It would read all the papers in both the illnesses it's researching as well as adjacent illnesses. It would do a full review. It would self-evaluate itself. It would do the ethics check, etc. All of these are essentially part of a multi-agent system, and each one of them is a different agent. So I'd like to jump into some of the results of this. Of course, you can do this many, many times as well, because it's essentially computing time. And we've seen really great results with this in discovering different hypotheses for especially unsolved illnesses. And I'm giving just a medicine example, but indeed you can apply it in many different fields. Let's actually play this video if possible.
With the answer in 2 days that it had taken you around 10 years to find, what was your reaction?
My reaction, I was shopping with somebody. It was a Saturday afternoon. I was shopping with somebody, and I said, please leave me alone for 1 hour. I need to digest this thing.
Wow. Okay.
So, and then the first thing I said is, I wrote an email to Google, say, you have access to my computer, is that right? Because otherwise
you thought they were cheating.
Yeah, absolutely, yeah. Because and also, sometimes I use ChatGPT or whatever for improving my English. So you have access to this chat. He said, no way. He said, this is all based. It's not just that the top hypothesis they provide was the right one. Okay, it's that they provide another 4, and all of them made sense. And even for one of them, we never thought about it, and we are now working on that.
So this is Dr. Jose Panades. They've been working on a secret kind of approach to figure out various illnesses for 15 years. Then the system was able to come up with the similar output in literally 1 day, and more so as well. And then maybe another one. This is an expert in the genetics field. He has, I think, more than 1 million followers on X, by the way. And we demoed it to him. He actually cured some illnesses as well, again, using genetics, but it took him like 20 years. And what he said was, after what I've seen today related to an AI model, I can confidently claim that the scientific process will never be the same again, and that he's 99% certain that all diseases, including cancer, will be cured within roughly 10 years. So these are some of the feedback that we're getting. Again, this is one example from medicine, but what it's telling is that it's really making us go beyond what we thought was imaginable. These systems are able to do what a human would do probably in 100th lifetime of her or his. And we're going to see results like this in all of all of the approaches and all of the multi-agent systems that we're going to be building. So let's be ready for that. And as a closing thought, the last thing is that we're doing lots of work in combining AI and systems, and this is going to be super important as well. Maybe comes as a second thought, but systems are a huge bottleneck right now. They're improving with the Moore's law, which we thought was exponential, but it's actually sublinear compared to how fast AI is going. So you will see AI and systems coming together more or less in everywhere. That's because the systems will need to catch up to be able to really deal with all the demand that we are seeing when it comes to AI. So these are some initial thoughts. We can answer more questions in the panel as well. Thank you all for your time.